Hello YouTube RJ. Hey, today got something new in. If you remember a few videos ago, I got in the Model 1010 Dexter low noise amplifier, played with it, found it on eBay. It works well, but it's not going to be quiet enough to do some of the things I'm going to be doing in the upcoming project. So I really needed something that would really get down low in noise. And if you remember that video, I spoke about maybe we would do a project and build one, and a specialized one, particularly for extremely low noise. This is a great general purpose bench low noise amplifier, but I needed to take it to the next level. Well, I did a little research on that to start that project, and I came across a number of projects and hints and ideas of people doing the same thing. And one of them was, I found a gentleman on EEV blog who spent quite a period of time perfecting one for himself, that he put all the information out. He's got the schematics, you can build your own. He now sells them complete on eBay. And when I got to looking at building it, it looked like what I wanted. Started looking at the parts and stuff. Really, I couldn't build it as cheap as he had it up on eBay for. So he sells them on eBay. I'm going to jump over the computer in a minute and show you. But let's take a look at this real quick. Before I do that, I'll show you where I got it and what all information he gives you. And he's done a really great job. And we'll take a look at it. Make a case, drill a case, and put it in. Doesn't come in a case. I really like the specs. And here's what you get. Get this out here. You get a little board. Let me go ahead and grab my static strap and slap it on, just to make sure I knock any static out. No ESD, please. So here's the board, and here's the little LEDs and switch that comes with it. Once you're mounted in, you put these LEDs in through the thing. I'll show you on the computer in just a moment. Runs on a 9-volt battery. Has an in and 2 outs. It's a multi-stage amplifier. And at one stage, the first stage, it's 250 gain. And at the second stage, which is the final stage, is the 1000 gain. So it's a 1000 gain amplifier. Has very, very low noise. You can see he's put a lot of effort into controlling noise. He's got a nice enclosure here. Then he wants you to put it into a metal enclosure he's designed it for. And as you would just happen to be, we got one right here. Well, that's obviously because I knew what I needed. So I went ahead and ordered. This is a Hammond 1590Y enclosure, die-cast enclosure. This is what he's designed it to fit into. It's a common enclosure. One of the things we're going to do today is we're going to get that in here. So let's jump over the computer for a moment. Let me show you what this, what I ordered, where from. I'll put the link in the description too, in case somebody decides they want one of these. And then we'll bounce over and get started on getting this case ready to get this board mounted in so we can try it out and see how it works. So, okay, so here is the amplifier. It's by Tyler Richard. It's eedesignpro.com projects LF_LNA/revision B. And I'll put this link in the description of the video for you so you can get to it easily if you choose to be interested in this. There's a link here to buy it on eBay. And he lists right down the line some schematic. It's not like he kind of hides anything. You can download the schematic. For example, let me pull it over here a second. Well, let's just go look at it. Here's the schematic. Great detail schematic, part numbers, everything. You could build this yourself. I was actually thinking about it, but when I looked at how nice a job and how much work he did to get the layout of the board just right and to get everything just right, the parts were going to cost me basically, by the time I got a circuit board, what buying it ready-made. And since we're in this big project and I've got a lot going on there, I decided just to buy it from him. Hopefully it helps him out a little bit. And he gives you the schematics. He gives you a
Really good drill guide to drill your case. Tells you which case to order. You get this nice drill pattern on where the holes need to go and such. So that's handy. He gives. I asked him for, and he gave me the little label artwork with my serial number on it. Mine's serial 30. Then on top of that, you go down. You've got the drill guide. He gets into talking about how the protection works, how he protects it from being damaged. He warns you not to do negative inputs. That's what the little red light shows you. If you use the case he provides, this is kind of what it should look like. Goes in and shows you exactly what he does for testing. He uses a rodent short oscilloscope, and he takes you through exactly what he does for all the tests. And then every unit he's built, he provides you the data. And here's what the data, I'll pull over and show you. Here's what the data looks like once you unzip it. You get an image of a frequency response to let you know what the frequency response of your unit looks like. He gives you a Excel spreadsheet with just all of his testing data. I'll give you a quick look of it here, of all the testing data. But he also gives you this whole folder of screenshots that lets you see, for example, all the different shorted input tests he does, what the RMS noise floor is with it shorted. He does a lot of testing with shorted inputs under different circumstances. And then, he does things like show you the sine wave gain, step responses. So, he gives you all the different data. Here's the frequency response again. Gives you all the data to really let you see how yours performs. And I'm sure you can see it's pretty low noise. But we're gonna find out. We're gonna be doing a little testing of our own here in a minute, and we're gonna use our equipment, and we're gonna see what we think of it. So with that, let's jump over to the bench, put this thing together, and let's get some testing done.
Okay, so we need to get this thing marked up to where to drill all these holes. And so the first thing I want to do is mark out these 3 LEDs on his plans right here, so that you can see what I'm doing. And he's got it marked here as the center line of those LEDs is 2.1578 inches. It says from the flange. Well, I was trying to make sure I knew what the flange was here. So here's what I did. I measured that distance, and what I found was the flange he's talking about is the flange here that hits the box when you put the board in. Well, it's kind of hard to measure out here from the inside of that flange. So what I did was I realized that, if this flange is going against this box, I've got some distance to the outside. So I measured that, and it's 0.1 inches. So I'm going to add plus 1 inch, plus 0.1 inch right here and make this 22. So this dimension from the outside is going to be 2.2578 inches to the center line of the LEDs. So first thing I'm going to do is I'm going to put me some tape. I'm going to figure out about roughly where that is. Set up my calipers here. 2.257. A little too much. We're going to go about 5/8, since we're so close to 7/8, so close to 6. So I need my tape running right across about there. Okay. So I'm going to take me a piece of tape, and I'm going to put it down in that area like this. And I'm going to take and drag this You can see my calipers made a line there. So I know I'm roughly in that area. So here's my line right here. And we'll go ahead and use an edge. Okay, so my LEDs need to fall along that line. Now I've got to figure out how I measure it out. This would be interesting. Probably need to do the center is what I need to do. It says across the board is 2.8. So I think what we're going to do is we're going to center it up, do every measurement for that off the center. So I'm going to measure the box. I've got 3.58. So that's going to give me 3.58. So I should be 1.79. Should put me dead center. So I'm going to say that should be half the box. So I'm going to take and put me a mark there. Okay. So that will be the center LED. And then from each side of that, 0.75 inches gives me the other LED. Okay, so that's one LED. Next LED is going to be right here. And the next one's going to be right here. Make sure that looks right here. From that LED is correct, and he's centered. So that should, this right here should be my 3 LEDs I need. According to this, I need an 1/8 inch hole. So I'm going to drill 1/8 inch holes there. Now, we need to do the same thing for these to come through. So I'm going to go ahead and tape up across here, something like this. Now, we want to make sure these are centered up. They are. So I need the same center that I put the LED, just like that. I need that same center here. So that gives me the center point lined up, this LED to here. And these are, according to here, the same thing, 0.75 inches on the BNC. So that we're right back to where we were. So they're all going to line up. Okay, so we're going to have one right here and one right there. This will be the center location of our BNCs. But now we got to figure the up and down. This looks a little more complicated. He's got a lot of interesting information here. It says minimum clearance to enclosure inside. It says maximum for LED leads to reach. So you want to be between these two measurements lines here. And what he's showing is, well, what is he showing me? It looks like I should be a little bit less than 0.750. Need to be between 1/2 inch and 3/4 inch. But I don't know if he's including the thickness of this. I don't assume he is. So my measurement here would have 1/10 inch more. So I'm going to shoot for about 0.7 inches. And I'm going to think that we need to be, and let's see, he's showing it measured from, yeah, that would be facing this way. So yeah, I believe we need to be right along that line right there. So let me see what that looks like. If this board goes in, these centered, Yeah, that looks all right. I think that'll be perfect. So here's where I need to drill my holes for my BNCs. So what I'm going to do is I'm going to go off camera so I can go out to the garage on the drill press. And I'm going to drill these out to the proper size, 1/8 inches for these. I'm going to put 1/8 inch there. And then he says a 1/2 inch hole for the BNCs. Let's verify that. Before I go drill a hole, find out I made it way too big. It looks like it's going to be about right. 1/2 inch looks about right. So I'll get those drilled. What I'm going to do off camera is I'm going to drill those in the drill press. I'm going to knock this down with a little bit of sandpaper, very light sandpaper, high grit, or I should say fine grit. Wipe it all down. I'm going to shoot a coat of white on it all. Let it dry for probably a day. I'll be back, and what we'll do is we'll go ahead and have the laser put that tag information on there, and we'll mount this thing in, power it up. We'll test it out, see how it works. So, hey, I'll be back probably tomorrow.